All right, we're going to continue on, and not as extensive as of a review as we had last time, but just a couple things. By now, you should be comfortable with creating a database, dropping a database if you don't need it anymore. You should be familiar with inserting data into a database with the insert into, how to do simple queries with a select, how to modify data with an update, how to remove data with a delete. As far as the summary reports, we quickly went over the min, the max, etc. All right. We had some problems with the loading and exporting, so we're going to look at that some more today, but down a little further. And I showed you the running a script. What I'm going to do today, and we'll see how long this takes, is I want to go over part 3, which is on using more than one table. And I'm going to talk about a few things that are not in the handout, because I just want you to hear this terminology. My hope is between today and tomorrow we'll finish this. Then on Wednesday, we're going to create a brand new database. When I say brand new, it's not technically, it's new to you. So when we go in there and we create that, and as always, if you haven't done so, please get into XAMPP, bring up the control panel, start up Apache and MySQL, go into the MySQL shell, and do your MySQL -u root. All right? And what we've been working with so far has been the Southwind database with products. We're going to create a database just so you see what we're going to be doing. That's called Acme. We'll do this not today, but we'll start on this tomorrow, because while we do it, I'm going to show you how to use the more GUIized tool in order to do this, because I think you'll probably appreciate that more after working with this thing from the console. But let's see, show tables. So we'll have, and these are just copies, so we'll have 3 tables in there, but see, you're all in here. So there you all are, all right? And we're going to go through and do that, but we're going to do it in stages. It may take 2 days. We're going to build it first and then talk about when we build it, wow, that's not really done very well. How could we improve it? So we're going to improve it. Then we're going to go and we're going to improve it again. All right, just so you see the different ways that all of this stuff can be done. We'll start talking about some of the stuff that's in there today. My hope is, though, that by Thursday, and we'll see how it works, but by Thursday, I'll be able to give you your first worksheet, and I'll give you Thursday to work on it, and part of Friday. Remember, Friday, good, bad, or indifferent, from I think it's 9:50 to 10:35. That's a 45-minute stretch. We're going to have the middle schoolers come in here, and we're going to build, in 45 minutes, we're going to build the guessing game program, but I'm not going to put in all of the exception handling and stuff that we had, so it's going to be really simplistic. From what I hear, there are going to be about as many coming in as we have in this class. So that's good. So you'll be able to walk around and help people. And from what I hear, they want to get them in and get them out, so it literally is going to be 45 minutes. But so then from 8 until about 9:45, you'll have lab, and then from about 10:30 till 11:55, you'll have lab. We're going to have one more group in 2 weeks from Friday. I don't know if it's going to be one group or 2. First I heard it was 1, then I heard it was 2, then I heard it was 1 again, then I heard they weren't sure. All right? So it's going to be either one group or 2, and we're going to be doing the same thing with them. That should be it. Charles has had discussions with Jeremy Sutton. You may or may not have seen, or you may or may not know who he is. I know some of you know who he is. But we both have expressed our concern over, you lost a whole class period that Friday, and you're losing between these two almost the equivalent of another class period. And you say, well, that's good. I don't have to be here. I don't have to do this, do that. I get that. But those are 2 days, conceivably, you could have had lab for the entire period. That's the way I look at it. So you lost 2 lab periods. I don't like doing that. All right. And they know my frustration with that, because we've got 10,000 things to cover and 1,000 days to cover 10,000 things, type of thing. So there's always plenty of stuff that we really can't get to just because there isn't time. All right, so again, I'm supposing or expecting that everyone is into XAMPP right now. And I'm going to do this a little bit backwards. And what I mean by that is I'm going to go down to the end of this section, the very end, and I don't know what page that is, but I can tell you if you do have your handout. This is all the way on page 24. All right? And on page 24, they talk about backup and restore. So I'm very quickly, hopefully, going to show you how to back up your database. Now, hopefully this makes sense to you, the importance of backing up a database. All right? Because if for some reason anything happens to it, somebody hacks it, all right, you get a power hit, there's all sorts of things that conceivably can happen. Somebody goes in and removes it. Oh, I didn't mean to do that. Well, you did. All right. And what I'm showing you right now is we're going to back it up, but we're going to back it up from a command line. Normally, what you'd end up doing is you'd have some kind of an automated script that would run every hour, every 10 minutes, every day, every whatever, and it would do this same work. All right. Plus, the documentation that's in here is not real stellar. How do I know that? Because I tried following their documentation this morning, and it didn't work. And I tried it about 10 different ways, and none of them worked. And then I started, looking online, and that didn't work. All right, so if you ever watch these associated tapes that are out there on the YouTube channel under databases, I've got about 15 minutes of me saying, well, that didn't work either. All right, and then I stopped and said, the hell with it. And what I'm going to do is I'm going to stop this tape and try to fix it myself, and I did, and then I got that to work. So that's what I'm going to show you. All right, now, in order to be able to get this to work, and you have to tell me if this doesn't make sense to you, right now on my screen, and probably where you are, this is known as the MySQL console. All right, so we are in a part of MySQL. What I didn't know is if you want to back up the database, you can't back it up from right here. You've got to go up one level. So if I type in exit, I get to here. And you should do the same thing. If it doesn't kick you out, but it puts you right here, that's a good thing. All right? Because now we can run the backup command, which, you might laugh at the name, but it's called MySQL dump. All right? And we're going to run that command in just a minute. There's a bunch of different ways that you can run it. Okay? And some of them will probably work and some of them probably will not work. This, for lack of better words, is the command. Please don't start typing it. Because for you, it depends on where you want to back the database up to. Only you know where your desktop is. So your desktop might be D:\desktop. It might be C:\/ or something else. Might have your name on it. But I think, I'm assuming here, everybody knows how to get to your own desktop and how to get where that is. So for instance, if I go here, okay, and I go to my desktop, well, I don't want that because I don't want desktop. But if I choose something that's in here, for instance, if I choose this folder, my C# folder, now I come in here, now notice it gives me the path to my desktop. I don't want the C#, but I want all of this stuff. That is the path to my desktop. Does that make sense to everybody? So I'd like you to find the path to your desktop. Then grab everything that's in the path right here and copy it to your clipboard. All right, because that's what you're going to have to put in for your MySQL dump command. All right. What's nice is I'm going to be able to show you this ideally in about 5 or 10 minutes, where I floundered for about 20 or 25 minutes with it this morning. Yes.
So do you want it to be for sure on the desktop? Or
No, you can save it anywhere you want. All right, that's the question was, does it have to be on the desktop? That's just a natural place to save things. But let's assume that Brady was, everything that he's been doing, all the documentation, etc., he's created a folder on his desktop that's called databases. Well, you can put it in there then. That's not a problem. I just wanted it to be in some standard place where when we get done, you can see it and you can see what it looks like. All right? Okay, So if you look up on the screen here, this is the command. Now please, before you start typing, a couple things. You'll type it right from right here. I'm going to do the same thing in just a minute, okay? I have it here, but I moved it to another directory. But it's MySQL dump space minus U because for user, space root because that's your username, space minus P for password, space minus databases. You can back up more than one database at a time if you want to do that. And that's why it's databases. So if I had like Southwind and Acme and a bunch of other ones, etc., I could do that. But it's minus databases space Southwind. I'm assuming that when you created your database, you called it Southwind, as we did in class. If for some reason you did not, all right, so let's say Colin called his database Colin, which would be fine. He'd have to change the Southwind then to Colin. All right, space, then a greater than sign, space, and then this is your path right here. All the stuff in blue is your path, space, and then whatever you want to call it. I called mine backup underscore southwind.sql. Now, some of the documentation, again, if you look up on the screen here, some of the documentation says you should put that in double quotes and you should put a semicolon on the end. Don't do either one. Because I had problems trying to put in the double quotes and trying to use the semicolon. So please put it in like this. And if you look, one more time, I'm gonna copy it into here. All right, so come on. Okay, well, I thought I was gonna copy it in there. Here it is. All right, so if you copy it in and it comes back and it says enter password, that's a good thing. We don't have a password, correct? So I hit enter and it's done. It's all been backed up. So I'll put this back up there. It's a little bigger for you to see. You can call this anything you want. So if Amin wants to call his amin.sql for the backup, that's fine. Most of the time people put backup in it either at the beginning or at the end. If you try it and you think you typed in everything correctly, but you get some kind of an error message, then raise your hand.
I didn't get an error message, it's just like the limited database thing. Like I forgot to say.
Did you get out first? Did you go up one level by typing an exit? To go up one level, you have to do that first. Because this is a utility that cannot run under the MySQL console window. All right. One more time, if you look up on the screen here, please. Now, if you look, what I've got here is I now have, I should have, well, I don't know where it is, but the file should look pretty much like this. So if I open it up, it's showing me everything that it did in order to build everything up until this point. All right, yours isn't going to look exactly like mine. I've done some stuff you haven't done. But hopefully it saved it. If you think you ran everything and it looks okay, but you can't find it or whatever, then let me know. So again, here was the command if you were a slow typist or whatever. There's two reasons I'm showing this to you. Number one, that when you do your worksheet, when you do your worksheet and I ask you to do things, you all have your own copy. All this stuff, you can't copy this stuff to a folder and give it to me and have me have it run. This is all existing on your hard drive right now. And we could actually have you copy it, and that's such a pain. So what you're going to do is on this worksheet, you're going to write down the command you used and then the output of that command. So in other words, if I say, how many products in the Southwind database have the word pen in their product code? So you're going to show me the query to do that, and if the answer is 6, You're going to show me the query, and then you're going to put in 6. Does that make sense? That's what you're going to do. And one of the questions, or probably the last one I will ask you on there, is how do you back up the database? This will be it. The only thing you'll change is that name right there, and I'll say assume you're backing it up to your desktop. Okay, so I'm going to ask you to do that. So you will be putting in this as part of what you do, all right, for the first worksheet. Hopefully that makes sense to everyone. The other thing is now if the power is hit or something like that, you really could go back. You'd have to look at everything that's in there, but you could go through that file and you could recreate the database if you had to do that. All right, some people, what they do is they wait, they back it up incrementally, which is really the best way to do it. So you're just learning how to do this stuff. So let's say that, Ethan decides he's going to do a bunch of this stuff on his own. All right, and he's like, I'm going to go back and I'm going to go through everything we've done so far, but I really, just in case I screw up the database, well, you could do it again and call it Southwind 2 like I did. But he says, I don't want to do that. So he grabs everything he has up until this point and backs it up. That way, if something goes wrong, he's got a backup of what he originally did. All right, really good developers find ways to make copies. All right, if you didn't hear my own story of woe, and I'll keep it short and sweet, the 2 terabyte external drive I have that's this big, I managed to drop it and ruin it. I don't know how, but it wasn't dropped from basically from this height. But it was so bad, everything in there was unrecoverable. Everything I hadn't backed up again, I have now lost. All right? So that's why you back stuff up. Now to get back in again, all you do is your MySQL -u root. Boom, and you're back in. Yes.
What'd you say to put for the password?
Nothing. Just a space. Because we don't use a password when we go in. All right? I'm going to show you, if we have time, right near the end, how you can actually set up user accounts if you want to do that. So if you wanted to do something on your own that was private and you wanted to make sure no one else could get in there, you could create a user named Colin and give it any password you wanted. Then if you didn't show that to other people, the only way anybody else could get in would be to know your password. So I don't see hands up, so I'm taking at least for granted that either you got it done or at least what we did made sense to you. All right? So I'm going to jump back up to the beginning of this section. And that is page 17 that says more than one tables, which is great English, isn't it? All right. So far, what we have in here, so far what we've done, we have a single table. We have one database called Southwind, and we have one table, and that one table is called products, okay? And there's absolutely nothing wrong with that. But if you keep putting in more and more, keep going in and adding more and more and more fields, pretty soon the table is going to be unmanageable. And what do I mean by unmanageable? Well, right now, if I come in here, and again, your products may not look exactly like mine, it's no big thing. But that isn't bad. But imagine that I put in 10 more fields. And now every time I run it, it's about twice as big as this. So it's starting to where this is really hard to read because it's taking up the whole screen and it's going up to the next line, etc. Plus, a lot of the stuff that's in here doesn't really seem like it should be in here. That's what happens over time. All right. So, if I'm still confusing you, imagine this. Let's say that I create a table. All right. And let's just say for that table, you don't have to do this. But let's just say I come in here and I create a table. And I decide I'm going to call it employees. All right, and so this is going to be the name of the table. And in there I put in a first name, I put in a middle initial, I put in a last name, I put in an address, I put in a city, I put in a state, I put in a zip, and let's say a cell phone number. All right? That stuff, it pretty much all goes together. I think everybody'd agree with that. All right? But it's called employees, and yeah, that's all information about employees, but let's assume a couple of other things. First of all, let's assume that all employees work in a department, okay? They're at a company. So I'm going to put in here department name, department number, all right, salary. We'll just leave it at that, all right? And, well, right now, I do not have a good name in here. There's not a good field name in this right here for a primary key. There really is nothing in here that necessarily is unique. I'm not asking you that, I'm telling you that. So I come in here and I decide, okay, I'm going to put in here employee ID. Now that's pretty good. And all of this data does go together. It really does. However, let's just say that I have, and I'm making this up, so don't worry about it. I'm going to remove this in just a second. Let's assume that I have 5 departments, all right? So I've got 5 different departments. And under my 5 departments, again, I'm going to remove this in just a second. I've got Department 1, oops, and Department 1 is Information Technology. And then I've got Department 2, and again, I'm gonna just say shipping, and I've got Department 3. I'm gonna make 5 departments here. And that's gonna be accounting. I've got Department 4, oops, and that's gonna be receiving. And finally, I've got Department 5, and that's gonna be payroll. All right? So, for every one of these employees, I'm going to end up putting in there either 1, 2, 3, 4, 5, and I'm going to end up putting in there one of these values. Does that make sense? All right. But now I've got somebody who's in a hurry one day, and for the person who works in Department 3, they put in this. They put in 3 for the department, but then they put in this. The way that currently exists, the system will not flag that as being an error. In here, it will not flag that. There's no safeguard that we have in here to make sure that that doesn't happen. So now I've got the same department number in there with 2 different department names. It might not sound like a big thing, but it can be a big thing. And later, the same person comes in there and they also don't know how to spell. So they put in there receiving. So now I've got receiving in there twice spelled differently. And I've got accounting in there twice spelled differently. All right? Plus, I've got the word receiving, accounting, information technology, etc. every time I have this. So that's not really a good thing. All right? So instead, what I'm going to do is I'm going to come in here and I'm going to create a second table called departments. And it's going to have in here a department ID. All right? And it will have a department number. And it will have a department name. And I kind of showed you already what it'll look like. You know, so 1 will be information technology, etc. Now I've got this. Now that I've got this, I only have to put shipping, receiving, accounting, payroll, and information technology once. Why? Because now I can get rid of this field. All right? And in order to be able to bring all this information together, I'm going to have to do what's called join these tables. That's what this section is about. All right? So what I'm saying is the terminology that's normally used database-wise is the department number functionally determines the department name. So if I know your department number, I know the name of the department you work in. Does that make sense? All right. And there's another one in here also. Now I could say, hey, could somebody guess what it is? And maybe you would, maybe you wouldn't. And sometimes people like playing those games and sometimes they don't. So I'm going to do this. I'm going to create one more field that I'm going to call zip, city, state. It's kind of a long name for a table. But normally, if I know your zip code, I can tell what city you live in and I can tell what state you live in. That's how it works. You know, maybe you've had this happen. I know for a long time where I've got the house still in Rockton, For some reason, I was getting called every day, at least twice, by different kind of telemarketers, and they would never ask. They would just say, "What's your zip code?" And I tell them that when I talk to them, and they'd say, "Oh," I'd say 61072. And they'd go, "Oh, Rockton, Illinois, correct?" And they knew that because the zip code functionally determined, all right, the city and the state. Why am I telling you this? Well, now I'm going to come in here. I'm going to call this zip ID, and I'm going to call this zip code, or just zip is fine. And I'm going to call this city, and I'm going to call this state. Now I can get rid of these two fields. So you see what I'm doing? I'm taking the one big table and I'm breaking it into smaller tables, and it looks like I'm making more work, but in the end I'm making less work because I'm eliminating as much of the redundancy in here as I could possibly eliminate. That's what working with databases is all about. Now, Brady mentioned he was here this weekend for the open house, and he said that Ryan, who teaches in the class after me, one of his students is some kind of an SQL programmer or something. And he had asked Brady what they were working on. Well, this is the kind of stuff a database programmer will be doing all the time. You're given a list of requirements, and you're told from that list of requirements to build a database design. That's what this is. We're designing the database right now. And to be honest with you, what I'm showing, this is almost what we're going to do come Wednesday and Thursday. That's the thing I showed you with all of your names in it. That's what I did. So we're going to first build it and put everything in one table. Then we're going to separate it out into 3 tables. Could you separate it out even more than this? Yes, you could. There's different ways that you could do it. But what I'm just trying to show you is a natural way of doing this. This process that I'm showing you right now, this process is typically referred to as database normalization. Normalization is one word. So we are doing what's calling normalize, that we are normalizing the database. All right? When we had everything in one big table, if we have everything in one big table, it's not a problem, as long as we have a primary key. So whether we have one table or a bunch of tables, but assuming we have only one, if we have a primary key, then we are in what's called first normal form. Because first normal form, when you work with databases, there's actually one NF, that means first normal form, second normal form, third normal form, there's something called BCNF, then there's fourth normal form, there's fifth normal form, there's sixth normal form, and there's seventh normal form. Now most companies, that's way too much work. So most companies forget these even exist, and they do everything like that. They put their database in first normal form, then they put it in second normal form, then they put it in third normal form. All right? Okay, so putting it in first normal form just means that whether we've got one table or several tables, that each table or tables have a primary key. So I can check that off. We're already in first normal form. Okay, regardless of whether we had the original one or this one, we're in first normal form. Okay? In order to get into second normal form, you must already be in first normal form. In order to get in third normal form, you must already be in second normal form. So they build upon one another. Okay? Now, what second normal form says is you can't have one of the fields that are in here if we have a concatenated primary key, which means if we have a primary key that consists of 2 fields. We don't have that here, but let's pretend that our primary key was a combination of employee ID and first name. Everybody with me? We're just pretending that for a second, all right? And if you have a primary key that's more than one field like this, and if part of the database, part of your fields that are in here only depend on one half of the primary key and not on both, all right, then you've got to break them up again into more tables. We don't have that. Every table we have has only one field in its primary key. So since we've separated these out, and since each one of the tables has a primary key that is a single field, that means that both I'm in first normal form and I'm already in second normal form. All right? When we had this, I'm going to throw this back in here just for a second and then I'm going to get rid of it. But when I come back in here and I put in city, state, and zip. So again, I'm going to get rid of these in a second. In this case, all right, in this case, if I know zip code, I know city and state. I already mentioned that to you. All right? So what I have in there is what I'm saying is I can figure out some of my fields in my table based on a field that's not the primary key. All right? So the reason for me grabbing these fields here and throwing them in another table was so I can get into third normal form. Now, do I expect you to remember that? Heck no. And there are a lot of things out there. You can go into Wikipedia, for example, and type in database normalization. There are a lot of really good documents out there. And I just spent 10 minutes going over it with you. There's a lot more to it than that. But if somebody comes in and they're a database designer, these are the kind of things that they have to do. Because quite often in a company, if you want to become a database designer, let's say that's Brady's goal. All right, he wants to work in databases because he heard there's a lot of money to be made in there. All right, this is the kind of stuff you have to understand and have to be able to do. Not always, but quite often what you have is you've got a company that for years has been using paper forms to do something, whatever it is that it happens to be. But they're using this paper form. And now the people who run the company say, that's too antiquated. We've got to take this and we have to put it in, have a computerized type of thing, etc. Well, then you look at that form and you start to think, okay, what in here would belong together and what in here should I start to separate out? It's amazing because I've had to do this for companies before. And you get a form. They show you something like this. And then you ask, you start going through it, you become an expert on the form. And you say, okay, I know what you want to do, I understand it. But you've got this field right here that nobody ever seems to use. Can I just ask you, what is it? I don't know. And you keep asking, I don't know. Okay, then we won't put, no, you got to put it in there. Does anybody ever use it? No. But we might, which is bogus. They've been using this paper form for years. Nobody's ever used it. It's just a waste of time. All right. Well, no, we need it. Plus, when you create this database package for us, you put it on the computer, it's got to look just like this. This is what you hear from people. Why does it have to look just like that? It has to look just like this because that's the data entry people. That's what they're used to doing. So it has to look just like it. That's why you got to leave this field in here even though no one's using it. So you have to try to convince them, no, you really don't need it. But if you can't, then you're putting in a bogus field that no one's ever going to use. And I've been on both sides of that. I've been able to convince people, hey, you don't need this. And sometimes, no, that's what they want, fine. All right. So we're starting you get this list of requirements, which might be a paper form, which might be one or more pages somebody has written down, which might be one or more pages somebody has in an electronic file. It doesn't matter. But then you have to create something like this based off of that. And the reason I showed you this is what they're going to do in here now is they're going to start talking about the fact that we need to have more than one table. All right? Now, there are 3 different types of relationships that you can have between tables. I'm going to write them here real quickly. There's one-to-one. There's one-to-many. And there's many-to-many. These are the 3 types of relationships you can have between your data. We're going to talk about all 3 of these right now. They're all on these next couple pages. All right? Now, the best kind of relationship that you can have is this one. One-to-many. That's what you would shoot for, would be to have one-to-many relationships between all of your tables. That's not always possible. All right? And if you say, what does that mean? That's what we're going to talk about in just a minute. When most people think about a one-to-one relationship, you think about husband and wife, all right, that kind of thing, boyfriend, girlfriend, boyfriend, boyfriend. I don't care, but you get the idea. It's a one-to-one relationship. So going back to this example here, if I decided for whatever reason, if I decided to grab these 2 fields, just those 2, department number and salary, and pull them out of the employees table and put them in a new table that was called employee details or something like that. Okay, so if I made a new table over here, and we'll just call it ED for employee details. I don't know if I'll have enough room otherwise. And I decided that in this table, I was going to come in here and I was going to put in, I'm going to need to tab one more time. So in this table, I was going to put in an employee ID, and I was going to put in a department number, and I was going to put in a salary. All right? And I'm doing that because I want to get rid of these two. If we assume that every one employee has just one department number and has just one salary, now the relationship between this table and this table, so this one here and this one here, is 1-to-1. So typically when you have a 1-to-1 relationship between two tables, there are two tables that you could combine into one. But for whatever reason, you decided to combine them into two. Now, I don't know if that totally makes sense or not, but that pretty much is the explanation of what that is. So if we look in here, I'm not going to do it in order, because I'm going to do it in what I consider to be the most natural order. All right, don't worry about moving around and looking at it, but I just want to show you this. Okay, so this is how the author explains the 1-to-1 relationship. It says, suppose some products have optional data. This is what the author uses. In the products table, the author is supposing that some products have a picture associated with them. Okay, not all products, but some products. And some products might have, like, they call it a comment, but it might be a customer review or something like that. But not all products. So the author says, I'm going to grab that information and I'm going to put it into its own table. But I'm going to relate it to the regular table. So this would be, like I said, this would be like employee details in employee. Does that make sense? All right. So it says, sometimes it's more efficient to take some stuff that's either optional or for whatever reason you decide to split it up and put it into its own table. All right. There is a 1-to-1 relationship between these two tables. Now, I'm mentioning this to you because this is one thing you're going to see. This is called a database diagram. And let me move it up a little bit so you can see all of it, or as much of it as possible. In this database diagram, you'll notice some kind of weird looking symbols. All right. If you see the symbol between the two tables and you see a thing that it's typically called a railroad track. All right. So that's what this is called. That means 1. So that means this is a 1-to-1 relationship. That's what they're showing you right there. On the other hand, you see this. This is called crow's feet. I don't know why, I guess because that's what they say it looks like. This is a 1-to-many relationship. So if both sides have the thing that looks like a railroad track, it's 1-to-1. So for every one of these, there's one of these. Or for every one of these, there's one of these. So there's only one record in this case. Every product details record, all right, basically is associated with just one product. Hopefully that makes sense. All right. On the other hand, every one product record is related to 0, 1, or more product supplier records. Every one supplier record is related to 0, 1, or more product supplier records. All right. And again, I'm not saying does that totally make sense. You'll have to take a look at this before it'll hopefully start making some sense to you. All right. We're going to jump in and we're going to look at the 1-to-many relationship. Now, sometimes some books equate a 1-to-many relationship to a husband and wife and their kids, because it's possible for two people to get married and have no kids, 1 kid, 2 kids, or more kids. That would be a 1-to-many relationship, which says for every one of these, we have 0, 1, or more of these. Again, I'm trying to give you non-computer examples because sometimes it's easier for people to associate with that. All right, so 1-to-1 would be like one spouse and one spouse. I've given this before, people raise their hands, what about Utah? No, I'm not, this is no joke. I'm just trying to explain this stuff to you. And there's different ways that you can look at one-to-one, all right? And I just showed you the one-to-one, and I just talked about the one-to-many, all right? Now, I did that, but even though I did that, your author didn't do it in that order, all right? So we're gonna now go back and look at it the way that the author did it. So we're gonna start with the one-to-many. But before we do, notice, so far we've had only one table, a products table. A practical database contains many related tables, all right? Just like, by and large, the programs that we created in C#, by and large, had one class. And that one class was the name of your program, it had a main in there, and you did everything in main. But as you saw, when we started to do things like create our own exceptions, what did we do? We created more classes, all right? And as your C# program grows in complexity, you'll have more and more classes. As your database grows more and more in complexity, you'll have more and more tables, all right? So the author says here, every product we're going to assume has a supplier. If each product has just one supplier, and each supplier supplies only one product, that would be a one-to-one relationship. If that was the case, then all you'd have to do would be to add the supplier stuff right into your products table. But think about it this way, all right? If you got a company that makes a product, I don't even care what the company is, all right? But let's say that you're somebody who makes a product for Menards or something like that. The chances are pretty good if you make one product, you're going to make many products. All right? There are companies that make just one thing. That's all they do. But more often than not, for any company you have, they're going to make more than one type of thing. All right? So one-to-one probably doesn't make sense. So it says here next, it says, suppose that each product that you have is supplied by only one supplier. And a supplier may supply 0 or more products. Then you've got a one-to-many. Now that confuses people when they hear that. So let's go back and look at this one. What if we pretend that every time we hire somebody, we stick them in an apartment, but we don't give them a salary? I think I talked about this last week. So every single time we hire somebody, they get put into one of those 6 departments we showed earlier. But they don't have a salary until, let's say that it's the first day and they go and they meet with their supervisor. Their supervisor looks at their educational background, their experience, they talk with them, then they figure out their salary. So in other words, their salary when they start would be no. That makes sense? They don't have a salary. Okay? So we can look at it, what if we did the same thing with departments? What if you get hired into a place, but they figure out your department the first day that you're there? When I interviewed at AT&T Bell Laboratories, I interviewed in the morning with one department and in the afternoon with another department. They were totally different departments. All right? And I was supposed to tell them which department out of the 2 I wanted to work with. What was your number one choice? And if that wasn't their number one choice, would I work for the other department? But if we suppose that you have that and you don't know what department you're in, okay, then we're going to have a situation like this. It would be possible if you had a brand new supplier, they just started. They just opened up their company today. So how many products do they supply? None. They just opened their doors. So it is possible that a supplier can supply 0 products, all right, because they're a brand new company. But normally it's 1 or more, not 0 or more, all right? So what they explain in this paragraph, probably much better than I just did, is they go in and they say, okay, these are your 3 relationships, one-to-one. For every one supplier, there's just one product. For every one product, there's just one supplier. That's a one-to-one relationship. Then there's one-to-many. Every one supplier can supply 0, 1, or more products. All right? That's a one-to-many. Sometimes there is absolutely nothing in common between like suppliers and relationships. What we're going to do after the break is we're going to build this relationship, and we're going to do it in two ways. So you're going to see it built first as a one-to-many relationship, and then we're going to throw out that and rebuild it as a many-to-many relationship, so you can see the difference. So what is the difference? Well, we'll go over it, but when you're running queries and the like, you'll get the exact same results, whether you've got a one-to-many relationship or a many-to-many relationship. So which one's better? You know, again, I've given this example before. That's like saying, which of your kids do you like more? All right? Most people can't answer that question, even if they probably do like one kid more than another. All right? So we're going to do that. So like I gave you that as an intro, maybe not the greatest of intros, but it's 8:57. Let's come back at 9:10. We're going to go into this one-to-many relationship. Before we do, just so you know, if you look up on the screen, because I was playing around with this a lot this morning, these are the commands we're going to put in. You can, if you want to, go directly from copying these and throwing them right into MySQL. I was doing it all morning just to see if it worked, and it all worked. So if you want to take, like this command, for example, copy it to the clipboard, then you're going to be able to take it, right mouse click, paste it right into MySQL. For those of you who are not good typists, you know who you are, that's a godsend. All right? Because I'm not going to spend a lot of time saying, now type in this, because we're going to copy it. All right, so again, let's come back at 9:10, please.